welcome to Turn On to Geometry. I'm Amy Erickson, your studio instructor, and I'm glad you could join us for today's show. Today, I'm going to have help to do our lesson, and that's going to come from our studio students. Why don't we start with Delia? Well, introduce yourself, okay?
Hi, my name is Delia Teposan, and I come from Laguna Nueva School, and I want to say hi to my family.
Well, thank you very much, okay? And go ahead.
Hi, my name is Yesenia Jauregui. I come from Laguna Nueva School, and I like to say hi to all my friends.
Excellent. And we want to say hello to your class, too, right?
Yeah.
Okay. Thank you very much, Mrs. High's class. Now, I'm going to need your help and your help for our first activity. You ready? We're going to be talking about spatial visualization. Spatial visualization. That's a very big word, huh?
Yeah.
Does that make you think of anything? What does that make you think of? Space, like outer space?
Sort of.
Sort of? Okay. That's what it makes me think of, too. But we're kind of be dealing with space as in how much space an object takes up. That's space. Visualization, visual, means to see. So spatial visualization is how we visualize things that we see in a three-dimensional way. You know sometimes how you might see a picture of something like in a catalog or something? Like you see a picture maybe of a chair. Well, you know a chair is not flat, but in the catalog, of course, it's flat because the catalog's page is flat. But you can visualize in your mind what that chair looks like in space or in 3 dimensions, right? Yeah. Well, that's what we'll be doing today. And to do that, we'll be using these little cubes right here. See these little cubes? Okay. This cube is a 3-dimensional object. It has 3 dimensions. Do you have any idea what its 3 dimensions are? Can you tell your partner what its 3 dimensions are? Everybody tell their partner. Why don't we take a look at this video clip from Math Vantage to see if you named the 3 dimensions correctly.
We usually think of the space and objects in our world in 3 dimensions. Most objects have length, width, and depth.
Depth can also be called height. So the cube that we're going to use has 3 dimensions. Were you correct? Did you label its 3 dimensions as its length, width, and depth, or height? If you did, those are the 3 dimensions we're talking about: length, width, and depth, or height. Now, this cube, by the way, is also a polyhedron. We made polyhedrons on last week's show. Remember, a polyhedron is a 3-dimensional shape made of polygons. So each of these faces is a polygon face, which is a square. So this cube is made up of polygon square faces, and it's a polyhedron. Just thought I'd review that with you. Now, for our first activity, you'll be using a lot of cubes. So I need you to gather some cubes, and we'll look at our first worksheet as we're gathering cubes. So get some cubes out, and let's look at our first worksheet. Okay, here we go. Our first worksheet has 8 different pictures on it, and what we're going to have you do is we're going to have you use these cubes. Notice that they just snap together. Here we go, snapping some of them together. Okay, they just snap together, and what we're going to have you do is build all 8 of these figures during your time. Now, you're not going to be able to build all 8 alone, so it's important that you depend on your group for this activity. So you each need to build 1 or 2 of them, and then switch the figure that you built with your partner, and then they can check if you built it right, okay? Can you do that? Yeah. You're going to have to work hard, though, huh? Because we have to build 8 figures. So it's your time to build figures. So I hope you finish building and checking all of those figures. We'll see how good you are at spatial visualization right now. I'm going to have one of the studio students pick out one of the figures that we built. So, Yesenia, can you give me one of the figures you built? Okay, I'm going to put this on the desktop. I want you to take a good look at the figure that Yesenia built here. Okay, you see it? Okay, I want you to look at your worksheet. Which figure did Yesenia build? 1 through 8. Take a look at it and tell your partner. Which figure? Yesenia, which figure is this?
7.
This is 7. Did you predict number 7? You want to try another one? Okay, wait, why don't we get one from Delia? Okay, this is a figure you chose. Okay, the chosen figure. All right, here it is. I'm putting it on the desktop here. Get a good look at it. which figure is this? Don't tell them, though, okay? We'll make them figure it out. Tell your partner, which figure is this? Delia, which figure is this?
Number 1.
Number 1. So did you get number 1? If you did, then you are getting much better at spatial visualization. Hey, okay. Now, I was kind of thinking, like, who might need to know how to do this skill? Who might need to know how to visualize something in 3 dimensions? And I was kind of thinking maybe an artist, because an artist they see things in 3 dimensions, but yet they have to draw things in 2 dimensions or flat. And it's really hard to do that. And so artists have special techniques that they use in order to depict 3-dimensional objects in a 2-dimensional medium. We have a video clip from Sunburst that shows us how artists do that very thing. Let's take a look at their secrets right now.
Eons ago, art looked different than it does today. The object thought to be the most important was made the largest in the picture. Or maybe all the objects in the painting were the same size. But in the 15th century, some painters began to use mathematics and perspective to create pictures showing the spatial relationships between objects. This picture shows things as they actually look to us, from a certain point of view. Perspective creates the illusion of 3 dimensions and makes the lines in this work of art recede to a single point called the vanishing point. Each train car behind an engine is about the same size and shape, but shown in perspective, each car looks smaller than the one in front of it.
Hey, why don't we be artists right now? What we're going to do is we're going to take a 3-dimensional object, okay, our cube, and we're going to learn how to draw it in perspective so it looks like it has 3 dimensions. Does that sound like something you want to do?
Yeah.
All right. Why don't we start by having a little help? We have some special paper that we'll be using today. It's called isometric paper, and there's 2 different types of isometric paper. There's a kind that has triangles on it and a kind that has dots on it. So you probably have some of that right now in front of you in your classroom. I'm going to demonstrate how to draw a cube on isometric paper right now. So what I need you to do is watch me. Okay, you ready? So first I'm going to hold this cube in front of my face, and I'm looking down at this cube, and I'm looking at the top face of this cube. Okay? Now you're watching me do this, and I'm going to identify the 4 vertices of the cube. Now I'm going to copy those 4 vertices on my dot paper. So here's 1, 2, 3, and 4. And of course, the 4 vertices are connected by their edges. So I'm going to connect their edges. Now I have the top face of the cube that I'm looking down at. Now if I were to twist the cube slightly this way, I'll see that there's a segment extending down from the center vertex 1 unit. So I'm going to draw that. And of course, there's a segment extending down 1 unit on the right and on the left of my cube. On the right and on the left. And of course, there's the segments that connect the base of my cube right here. Now I've drawn my cube from what would be called a top view or perspective. I'm looking down at it. Now I'm going to draw my cube looking from the bottom. That just means I twist it in my hand. Okay, and now I'm looking at the bottom of my cube. Again, when I look at the bottom of the cube, what I'm going to do is identify the 4 vertices of the cube, and I'm going to copy those 4 onto my paper. Okay, so here's the 4 vertices. All right, now if I twist my cube slightly, I'll see from the center vertex, there's a line segment extending up 1 unit. Of course, there's 1 on the right, and there's 1 on the left. And then, of course, there are the 2 on the base of the cube right here. So here's my cube as if I were looking from the bottom perspective. Hey? You know what? I think this would be a lot more fun if we did one together. Does that sound more fun than watching me?
Yeah.
Yeah. All right. So what I want you guys to do is I want you to get 2 cubes and connect them together. So let's see. 2 cubes, connect them together. Like you have a little tower of 2, okay? All right. Here we go. All right. Now, we're going to do this together. So get your cube. And I think I want to look at the top of it, okay? So you're looking at the top of it. And here we go. Here's my cube looking at the top. So, of course, I want to start by identifying the 4 vertices right here at the top. Pick 4. 1, 2, 3, 4. Connect them. Okay. Now if I twist it, I'll see that from the center vertex, I extend down 2 units. 1, 2. From the right vertex, I extend down 2 units. 1, 2. And from the left, I extend down 2 units. 1, 2. How you guys doing?
Fine.
Okay, good. Now we got to connect the base. Connect the base for me. Good. Okay, now you can put a line here if you want to separate the 2 cubes. You could use it as one big tower. And then I'm just going to color the top part, okay? Now, yes, our studio students are doing fine, but I know that this isn't something unless have you done this before?
Yes.
Oh, okay. If you have not done this before, it isn't something that you just do like that. So what we want you to do during this time, we want you to practice drawing your cube from the top to the bottom. You can try the side view too. It's a little harder, but you could try it. So during this year time, you're going to practice drawing a cube and a tower. So it's your time. So how did that drawing go for you? We'll share some of the studio students' work and see what they came up with. Yesenia, why don't we share yours first? Let's see yours. Okay, you were a busy woman here. Look at all this. Oh, my gosh. I see that you've drawn from the bottom and the top and the sides and even colored them so we know what cubes you were using. Wow. You're almost a professional at this, aren't you? Okay, Delia, let's see yours. You know, because we wouldn't want to leave you out. And, oh, my goodness. It looks like wow, this is a really good job here. Nice job, women. I hope all the students out there are having as much success as you are. Wow. Oof. You know, we're going to combine a bunch of the skills that we learned so far now into our next activity. What we're going to do is we're going to be showing you some pictures of some figures. Okay? Well, why don't we take a look at them now? Here are some figures that we have. There's 3, actually. And what we want you to do is we want you to just look at this figure. Just look. And predict how many cubes it took to make this. Then look at this one and predict how many cubes it took. And look at this one, predict how many cubes it took to make them. So you're going to predict, predict, predict. Then, when you're done, why don't you build each of these figures, count the cubes it took to build them, and record the actual. See how close you were with your predictions. You know, how did you make your prediction? So, during this your time, predict, build, it's your time. So how close were your predictions? Why don't we check with our first caller? Nick, how close were your predictions? Oh, Nikki. Nikki, what would you like to share with us?
My prediction.
Okay, for which figure, Nikki?
For number 1.
Okay, what is your prediction?
Huh?
What was your prediction for number 1?
7.
All right. Did you actually build it?
Yeah.
How many cubes are in it?
7.
Oh, wow. So you're a good predictor, Nikki. Great job, and thank you so much for calling. Wow. Did you guys predict that well on number 1?
Yeah.
Okay. Well, why don't we take a look at number 2? Let's see. What were your predictions for number 2? What do you have, Yesenia?
8.
8. You both had 8?
Yeah.
Okay, and you built it?
Yeah.
Okay, why don't you count it for me?
1, 2, 3, 4, 5, 6, 7, 8.
Did you get 8?
Yeah.
Wow. All right. Wow. Well, okay. How about number 3? What was your prediction? Delia, what's your prediction?
8.
8. And Yesenia, what was yours?
8.
Oh, wow. All right. So, Yesenia, why don't you count this one for us? Check it.
1, 2, 3, 4, 5, 6, 7, 8.
Wow. Well, looks like we have experts here. I'm sure you're experts out there. Nikki was. Wow. Well, you know, if your prediction isn't exact, that's kind of like what I expected. So I guess you were able to visualize those cubes that were kind of hidden in the pictures. Wow. Well, you know what? It's time for our last activity. And what we're going to do is we're going to have you make a figure of your own. I suggest you use between maybe 5 and 10 cubes. Now, before we do this, I want to talk to you a little bit more about spatial visualization, not just about cubes, okay? Now, I'm going to show you a picture that we took of the skyline of Boston. Why don't we all take a look at it? This is the skyline of Boston, and we've labeled 3 of the big white buildings in this picture, 1, 2, and 3. And what I want you to do is look at this picture, tell your partner which of these 3 buildings is the tallest building in this picture. Okay. You guys ready?
Yeah.
All right. So, well, what do you think?
Number 1.
Number 1?
Yeah.
Well, okay, wait a minute now. Okay, if I was standing here, I'd be standing like right here, right? Here I'm standing, and I'm looking at these buildings, and here's building number 1 right here. Now, building number 1 is clearly shorter than building 2. So why do you think building 1 is the tallest building in this picture? I don't get it.
Because it's more far away.
Uh-huh.
Oh, okay, so from your perspective, because you're closer to building 2, it only looks taller because you're closer to it.
Yeah.
Excellent. And I hope you out there were able to get that one correct, because building 1 is the tallest building in the city. And this is how we're gaining our skills on visualizing things in perspective. Great job, girls. And I'm sure you out there are doing a great job too. Now, I said that you need to get your cubes ready for the final activity, and you're going to use about 5 or 10 cubes. What you're going to do is you're going to build some sort of a figure with 5 or 10 cubes, okay? Now, besides this, what I need you to do is I need you to then draw this figure. Now, I'm going to demonstrate this one for you, okay? So let's go down to the overhead. I have my other drawings here already. Okay, I'll just move this over. All right. Now, I'm going to be drawing this figure. So, of course, I'm going to start by locating 4 vertices from one of the cubes. So I'm going to start with this one. And here are the 4 vertices of the top cube. I'm going to connect them. Now, as I twist this, I notice that this tower goes down 2 units from the center vertex. 1, 2. Okay? And, of course, it goes down 2 units on the right and 2 on the left. 1, 2, 1, 2. And now I'm going to connect the base. This is the tower. Now, as I turn, I see that there's another cube over here along the base. So I'm going to go 1 more unit along the base so that I can draw this cube right here. Okay? Here's this cube right here. Here's its square face right here. And here's its square face right here. Okay? Now I'm going to twist it to the left. On this side of my tower, I see 2 more cubes extending out. 1, 2. So I'm going to extend out 1, 2. Come down 1 unit and along the base to connect them. 1, 2. Of course, I need to put the top on. There. All right. Now, I'm just going to do a little more artistic stuff here. Now I've drawn my figure. Okay? During this short time, you need to each pick a figure that you're going to make, draw it on your paper. Now, when you get done, switch your papers with each other, okay? And then see if you can build each other's figure from the drawing. It's your time. So we switched figures and switched drawings and we're trying to build each other's figures. So let's see how that's going. Did you finish, Yesenia?
No.
Can I borrow your paper anyway? Now, this is actually Delia's drawing, right?
Yeah.
Okay, so you're trying to build this figure right here, right? Right here. Oh, you're done? Okay, let's see how this looks. Okay. All right, let's see. We've got 2 here. 2, 1, 2, 3 more. 1, 2, 3. And then 2 more coming out from here. Hey, this looks like you did an excellent job. And you didn't quite finish, but we'll do yours in just a minute, okay? All right, so you finished. Okay, let's see yours. This one is more complicated. Wow. Whoa, okay, 2, 2. Oh, it's backwards. Okay, see, it's even too complicated for me. Okay, 2, 2, 1, 1, 1, 2, 3, 1, 2, 3, 1, 1, and 1, 2. Wow. Wow, very complicated. Wow. Speaking of complicated, we have a challenge activity for you. This is called the Skeleton Tower. Take a look at this. This is a drawing of a figure that we made here at Teams, and we'd like you to predict how many cubes it took us to make this and than actually build it and see how close your calculation was. You know, we were talking about spatial visualization. Now, I have found a computer program that does just that, so you can practice your skills and play a computer game at the same time. Does that sound good?
Yeah.
I know, huh? All right, this is called Building Perspective. It's made by Sunburst, and let's take a look at it. When you first open it up, you see a picture that looks like this of a city. This is like buildings in a city block, okay? And I'm going to start with a 3x3 size city right here. Now, here are 9 different spots buildings can be in, these little green squares, in a city block. And this street is called Front Freeway. And if I'm standing right here, I see the front of this city block. And I see that there is a 7-story building and an 8-story building in front of me right here on the left. So right here on the left, I'm going to put a 7-story building, and behind it, a 9-story building. But I don't know how far behind it is, so I'm just going to put it here for now. In the middle, I can see a 6-story building and another 9-story building behind it. So here's a 6-story building, and behind it is a 9-story building. So let's put it way back here. And on the right, there's a 7-story building with a 9-story building behind it. So here's a 7, and let's put it here. And we'll put a 9 behind it. All right. Now, I want to go over here to Right Road. So I'm standing right here. So let's switch this to the right view. Right view. From the right, I should be seeing a 7-story building here. So that means the 6-story building is in the wrong place. So I need to move it. So I'm going to move this up and move this up. Some of this is kind of just guessing at this point. In the middle, I see a 3-story building with a 9-story behind it. So I'm going to move the 7 back, and I'm going to put a 3 in front of it. And I see a 9-story building here. That's right, because the other 9 could be hidden behind it. As I continue, I just keep placing the buildings in all the different views, and then I check to see if I'm right. So let's see. Uh-oh, that doesn't sound good. Your solution is incorrect. So I'm going to have to return to planning and keep working on this. But hopefully you got the idea of what we're doing. Now let's do something we can all do right now together. You just built a figure that your partner tried to rebuild from your drawing. I need you to get that figure back right now. Let's get our figures. Get your figures, girls. Right. We're going to do an activity with this figure. We're going to talk about its volume. Let me set mine down here right now. Now, the volume of a figure is generally calculated by how much space is inside of the figure. So I'm going to be calculating how much space is inside my entire figure in cubic units. That means 3-dimensional units, because cubes are 3-dimensional. Cubic units, okay? So I'm going to calculate the length, width, and depth of my figure, in other words. Now, it sounds hard, but it's easy, because this was constructed from cubes, right? So if I want to figure out how many cubes it takes to build this figure, I would just count them. Therefore, that would be the cubic or the volume of my figure. Okay? So I want to find out the volume of my figure, or how many cubes are inside my figure. You got it? Okay, so during this short time, I want everyone to calculate the volume of their figure. It's your time. So I hope you calculated the volume of your figure. Why don't we share the volume of our figures? We put them all on the desktop right now. So let's see. Let's start with, whose figure is this? Yesenia, is this yours? Yeah. What's the volume of your figure?
9.
So it's 9 cubic units, right? Mm-hmm. Okay. Mine is 5 cubic units. Delia, what's yours? What's your volume?
7.
7 what? 7 cubic units. Good job. All right. Was that very hard to do? Could you do that?
Yeah.
Okay. Now let's do another calculation with our figure. This is called the surface area. I'm going to demonstrate with a very, very simple figure. I'm going to demonstrate with this tower of 2. Okay? So why don't we take a look at this on the overhead. and I'm going to be demonstrating the surface area on the overhead, okay? So here's my tower of 2. By surface area, I mean how much paint or wrapping paper or anything would it take to cover the surface of every single face of my figure. So since all of the faces are squares, if I was going to calculate the total surface area of this figure, I'd have to look at all of its faces. So if I look at this face, I see 1 square. If I turn it upside down and look at this face, I see 1 square. So far, it's pretty easy. Now I'm going to turn it sideways, and if I look at this face, I see 2 squares. If I turn it again, I see 2 squares. And if I turn it again, I see another 2 squares. And finally, if I turn it again, I see 2 more squares. Now, I have looked at all 6 faces of my tower, and I'm going to add up the total surface area. So there's 2, 4, 6, 8, 9, 10. So 10 squares is the surface area of my tower. We might call it 10 square units. Okay, now, obviously, your figures are more complicated. So it's going to take a lot of calculating to do this. So I'm glad I made a simple figure. So during this short time, you need to calculate the total surface area of your figure. It's your time. I hope you were able to calculate the total surface area of your figure. We have a little thing we'd like to share with you. First of all, though, I'd just like to ask the studio students, how did you calculate the surface area of your figure? What did you do to calculate?
First, I counted top.
You counted all the faces of the cubes, huh? Because I heard you say that. You counted, okay, the top, and then...
The top, the bottom, the front, like that.
The front.
The left side, the back, and the front side.
And what did you do?
The same as her.
Okay, so you counted top, bottom, front, back, right, and left.
Yeah.
So you just counted. That's like the end of this show. So we have to go to journals. So I need everyone to pull out their journals. And I'll read you today's prompt. Wait a second. Before we do that, wait. Sorry, women. I think that we should talk a little bit about spatial skills and who uses them, okay? So I was thinking, Mike, I talked about an artist, but there are other people that might need to do this, like maybe an architect might need to do this because, they have to visualize buildings they make for us, so we have places to live and work, huh? Yeah. So why don't you write down today's prompt, what professions might need good spatial skills? Tell me what spatial skills are, and any other professions that you can think of that might need good spatial skills. Can you do that for me? Sure. Okay, get going, girls. Good job.
This program was produced by ETN, a service of the Los Angeles County Office of Education.